and we are live. All right, let me just set up. We're starting in 3 minutes. I need to set up first some things. Alright, this should be fine. All right. Now, today we are going to be improving a little bit on our render engine. The rendering engine is just a layer that deals with our rendering engine is just the layer that deals with objects, with shapes, and draws them using the Direct2D layer. So the Direct2D layer has its own mechanisms to, when you call draw rectangle and draw things, it does not immediately draw them, but it batches these commands in a command buffer, and then it essentially on end draw or on flush, it flushes everything on the GPU and draws everything. So our rendering engine just deals with the shapes and their colors and because this Direct2D does not deal with this. So this is a layer on top of Direct2D, which is in turn on top of Direct3D as far as I know. Because Direct3D has this, so in the sense that, like, I would like to kind of eliminate Direct2D in the future, so everything goes Direct3D immediately. But this is kind of difficult. So it's yeah, it's kind of difficult. Now the first thing about like measuring current performance of the rendering engine. As long like this is 4K monitor, and like now I have I will first have to research about first I will have to research about one thing is Direct3D anti-aliasing option. and there is this direct 3D anti-aliasing, and I have turned that to like 4 multi-sample anti-aliasing, which internally means that you are 4 times, actually you're rendering 4 times the resolution that you need. And I would like to see if there is direct, if there is essentially an anti-aliasing that is better in the direct 3D, but this is 11, I think. So oh, I hate this. 11 multi-sampling direct X 4 times MSA anti-aliasing, because let me show you. So in the node editor, let me first see if I have enabled the right project. Yes, I have. And in the node editor, there is D3D this control descriptor, which has this samples option. And let me just see where is this control descriptor used. It's used here. And sampling option, where is the sampling option used? Samples. If the descriptor samples, create render texture target with descriptor samples, multi-sample quality default. What is multi-sample quality? Default, standard, center. Okay, let me just see. Okay, this is create render texture target. This is a render texture target where you sample the texture many times, but only if the samples are bigger than the one. Weird. So okay, so we'll leave about the sample. So here now if I just go and open up this, we have 4 samples. So I think this kind of really, I'm not sure if it means that we're rendering 4 times the resolution, but we have to render 4 times the resolution if we have 4 samples, right? In the sense that this is like a texture. So if I go to the debug mode and let's open up a graph. Let's say that I'm just going to render the whole graph like that, maybe. And we're getting 4 milliseconds render time. This render time means that we take 4 milliseconds for the rendering engine to go through the whole these structures, and to render each, and then to like transform them, to deal with the transform matrices. So 4.4 milliseconds, this is render time, so 1 frame, 4.4 milliseconds. But there's a lot of nodes and shapes. There's like 1130 shapes that are iterated. So 4.4 milliseconds, but 4.4 milliseconds is quite a long time, I would say, for rendering something like that. And keep in mind, this is a very powerful GPU. But 4.4 milliseconds, it's not even the GPU time. So this is like CPU time. And then there is GPU time, there's around 0.3, 0.4 milliseconds is the GPU time. So GPU time is very fast. Which means that the GPU renders them very fast, but keep in mind, I will restart the task manager, just because task managers kind of, for some reason, Oh, and we're yeah, this is a little bit of a problem. We have to stop the training. I have some training procedures in the back, so I have to stop them. And like always, there's like always some Microsoft Defender things. But now, okay, so the GPU is like around 30%. Now 1 millisecond render time. Oh, it depends if I'm in focus or not. Maybe it gives priority to the GPU rendering that. Around 1 millisecond. But okay, this now, I believe this now can be simply improved by doing one thing. First, let's say that I'm just going to write on a notepad. I'm just going to write CPU render was 4.4 milliseconds, and then GPU render was like 1 millisecond. That's a bit generous, so I want to improve this. First, okay, so this is for multisampling. No, the backend is on Direct 2D. Direct 3D essentially is just like Direct 2D is on top of Direct 3D. But the rendering engine itself is just deals with how the shapes are transformed, because on Direct 2D you have to provide where the shapes are. I would like the rendering engine to be then transformed. It's just rendering engine, just the front end essentially. I would like that to be transformed directly to Direct 3D, and then there we'll be dealing with buffers. Yeah. Windows locked. Yeah, I mean, it's the node editor and the rendering itself is very decoupled. So the node editor could essentially run on other platforms. If you have if you export the graph and just do it CLI by CLI, like you can just do that. But the rendering itself, it's just Windows, because we're developing for Windows mostly. Like we don't have clients for Linux, so or Mac. So that's yeah, that's a bit shame. I mean, but we can. I mean, it's all just pretty much. You can extend that for other platforms, but yeah, for now it's Windows locked, which is kind of a shame. But also it's not CUDA locked, so you can run that on CPU or I mean, it's not, this not rendering engine is not for games. This is just rendering 2D 2D. I want to make it really fast just for the purpose of the node editor. So I want to be optimized so that the node editor will be optimized. I don't care about running anything else on this rendering engine essentially. But here, and the rendering resources. So rendering resources is just like a way to have access to some resources from each shape. So this is kind of resources that each shape can access, and this is done. So this is think that oh no, it's not a game engine. It's just no, it's just how you draw the layout, the specific, because C++ does not have any kind of no, Direct 2D or Direct 3D does not have any kind of built-in tools to manage with shapes, and it just like you're just passing literally, like you're just system calling. So you call like low level draw this, draw rectangle, draw this, and there's no way to say, okay, I'm managing that here there is a rectangle and then I can move this rectangle or I can transform that or whatever. So this is like another layer on top of that, on top of Direct2D. So I want to add here is, what I want to add first is like unordered map of string to, there is this, how this is called, graphics, it's in the graphics namespace, it's text layout, cached layouts. Oh, this should not, maybe layouts. Now I think one more thing we should make that instead of having just a text layout, I want to know how many times have I used this text layout. So I can, some things that are not being used, I can then kind of clear and see how many things are we actually caching, how many things are we actually clearing per frame. So what kind of data structures we can just do here for some easy things. Okay, when we access this unordered map of this here, I want to have this kind of struct here, maybe struct cached text layout, which will have a pointer to this graphics text layout and then just an integer of like used, of course this here, used. Now I can change this kind of structure immediately here, cached text layout. But I want to have like a priority queue where text layouts that are being, but in priority queue is very, because priority queue does not update after priority queue does not update after, so you will be filling up the priority queue with some things that are not how do they deal with this kind of iterative? Because if I'm using this text layout many times, and there are text layouts that are not being used, but you don't want to even like overflow this, so used parameters, so, and I don't want to access all of the text layouts on my every frame. I just want to kind of say okay, so let's imagine that we can fill up this is last time used, so I will be updating last time used, and should that be a long or should that be okay, last time used is 0. If this last time used, how often should we clear out some layouts? Should we do that on like okay, like on every Like you see, here is the problem. You should not when you're developing some like rendering engines, you should not have like peaks in performance. The performance should be very steady throughout the rendering itself. So because every peak you are doing is just saying that it's just spiking up the you can get spikes, you can get lags. So you want to clear out very commonly throughout the usage. So I think on 1 second, if I have like on 1 second, so let's go here, let's go, I will which layouts have not been used for quite some time. I want to clear them. So maybe I have an ID here as well. And each text layout gets an ID. And then this ID updates the last time it is used. So instead of an unordered map of text layouts, I should get an, but then there's like a log factor, and you want to avoid as many log factors as possible. But there's no other way to clear other than just iterating through the whole text layout thing and then saying, okay, this is last time is being used this way earlier. And a priority queue will kind of fill this priority queue always. So like I will always have this priority queue filling up with new text layouts, even though I have not been using them. So what kind of other data structure? So there's always like some log factor involved here. So okay, let's unordered map cache text layouts. Okay, so for starters, I can say that for starters, what I can do is just simply do that. I will clear the map always. On like 30, or no, I don't want to clear the map. For text layouts that are really cached, I don't want ever to be filled out. So okay, so I'll iterate the map and then remove all of these that are not actually necessary. Let's do that for starters, and then we'll improve on top of that again. When we are going to compute, create, transform, compute, render. Okay, so the problem is only on the text layout thing. So text layouts are rendered here, and pointers to this get layout. So now when I go into text shape 2D, this 2D, we'll find that this text shape D2D. What is its implementation? It gets a text layout. But there is a function create text layout or draw text layout. So there is this function create text layout, and instead of also font matters. Font family and font size also matter. So this also matters, even though there's no way to check font family and font size. Let's assume that this also matters, but let's assume that for now we kind of, if we once create a font with font family and font size, I can also cache fonts. So I can say m resources. I can also say std. I don't know if I can say unordered map because there's no caching function on the std pair, but I can say std pair and then std string, and there's string and float, and then there is this graphics font pointer, so cached fonts. And I can do like two functions. Let's just, instead of doing that, let's just go and do private. And here I will say just void get create text layout. There's const std string text. Also create font. What was this? Create font from string. Then std string font family float font size. Now that I have this, I can say that if so I have some iterator and cached. I take a look at cached fonts, find, then I can do std make pair font family font size. If iterator is not and cached fonts end, return iterator second. Of course this has to be graphics font. This has to be graphics text layout. Also I will create this kind of wait, what? And then I will return here. Then here is like m cached fonts, and then make this pair font family font size is m canvas create font from string, and then font family font size. Then I will return that. And here is the text layout is the same thing, but I want m cached layouts or text layouts. I think it's better because we're specifically caching text layouts. Maybe in some other things we'll be caching some actual layouts. So, this now we're finding here a text, of course. This is the same operator. This is the same iterator. Now, of course, this is second. Now there is just a little bit more logic here. IP second, less time used. Now, less time used has to have some kind of. I think the rendering resources have to have like some current time, and this current time will be current time. Will be updated each time the rendering function gets called. Less time used is equal to current time. Return IP second layout, of course, and then now if this is the first time we're doing this, it's just simple create text layout, but now we have to supply with font as well. So yeah. And now that font also, I can do. I can just point to the same font. But if I point to the same font, it means that the font is cached. Okay, and then basically you have the. Basically, you're just saying that this is the same. I'm just going to. Basically, what you're going to be saying is that if it's the same pointer to the same, if it's the same pointer, it's the same font. And again, I cannot use. I think pair is unhashable, so I don't know if it is unhashable or not. Let me just try. No, it won't give me errors here because there's no. But essentially, I want. I don't think this is okay, but I can do uint 64t. So I can do that. So uint 64t, and then I can say, okay, std make pair, and then font get ABI will return me a pointer, and then I can statically cast that pointer to a uint 64t. This will create the proper invalid type conversion. Why? Maybe 64. No. Am I missing bracket somewhere? This should be a pointer, right? Yes, it is. So why am I seeing like this? Okay. I mean, I say unsigned. Addresses are unsigned. So okay, so let's assume that that's true. Now let me create this pair here. Const lookup. Const auto lookup is this. Lookup here. Now this thing will assume that. Okay, cool. That pointer That pointer is fine. Another thing that I could do is I want to make this const. All right. Yeah, of course I cannot return this, but I think I can just do no. Yeah, of course. I need the last times used is and current time. And now, can I just do that? This and then layout. Now the compiler will know not to one more time look at the thing. I can just do that const, I think, but okay, it's fine. It's not now. It's fine. Now I can change in the shape. D to D. I can change, instead of creating directly from there, I can just go and do that, and this should work. I should be able to create one font size and then create each text layout independently, then just cache that, and if there are multiple, then that will be fine. Now to track last current time, I could update last current time to, so I can say void update time. It just will be a function. Let me just create a definition and current. For now, I will just say ++, even though I know that this will overflow. I will deal with this later. Current time, and then I will say maybe clear out like oh, I won't clear out right now because I don't think. Yeah, I think we should clear out because this will be just leakage. There will be full leakage here. Clear out. Clear out unused. Clear unused cache. And this unused cache will be. I will just iterate through all. There is a way to iterate through the to say cached layouts or cached fonts first. Cached fonts begin. IT is not cached. It's very important to do that. I mean that. Oh, yeah, I think we're iterating through the cached fonts, and we say, well, does the iterator change? It does change. The iterator does change, but you can say this if iterator dot sec. I mean, cached fonts does not have a lifetime. It does not have a lifetime. So cached text layout does not have a lifetime. Maybe it should not have. Maybe it should not be cleaned for now. Let's just clean text layouts, because cached fonts, I don't think it's any problem just to have 4 more pointers there. Text layouts are a problem. If last time used is, for now I will say, should we use absolute value here? If yeah, let's do that. Absolute value between the last time and the current time is bigger like than 30. For now, I'll just have a fixed 20. We have like this is at each second, so on like every second. We'll say okay, if it's bigger than or maybe bigger than 60, just to be like sure. If it's bigger than 60, then I will clear out the cache. So I will clear out this. So I will say it is and cached text layouts erase it. So I'm going to do that. Else it is next it. I think that should work. Now in the rendering engine, when we say render, there is a render shape group. There is no, the rendering engine does not care if you have kind of started the, or like there's no begin render, because each shape group it's itself begin render. Or no, actually it does care. I'm not sure. Do you have a repo? No. This is kind of this is, I'm working on this project for my master thesis and as well for our laboratory. So I'm actually kind of paid to do that. So I cannot share any. I can share the code because most of the code is even like some of the code is on public API, but I'm kind of sharing just to see like people to see how it's like production code like developed and actual like how we improve things. It's not made to just have like public repo and stuff. It's quite a large code base. It is based on quite a large SDK. Just the build process of this thing is enormous. It just takes a day to set up, you know. Pre-compute. Okay, so there are some things that here on the render. Yeah, there's no how long on this on the node editor itself. I have been working on like half a year. So like all of that nodes and all of these kind of things, as well as the rendering engine as well, this like in half a year. A render. Okay, so I will add one more function to this, because there's like reset debug data and render debug. But there's no actual, like, it does not care about, like, there's no, because it just renders each shape group individually. But this kind of, I did not want the rendering engine to care about when it's the time to update, but it seems that I have to care about that. Create shape group, compute transform. Compute transform is just a function that computes like the transformed bounds in the shape hierarchy. It's essentially like a shape hierarchy keeper. It's not even a render. I don't know if it's, I don't know, like I called it a rendering engine, but I don't know what it actually classifies as a rendering engine. It's direct2D. It's on top of direct 3D. Void, and then there's like a render. Okay, let's begin render loop. Maybe begin render, and then maybe end render as well. Should these functions be kind of on top of here defined? Begin render, end render. But if I define these kind of functions right now, this rendering engine is being used in like quite some downstream projects. So not only in the node editor, but in some other downstream projects. Because it's nice to keep a shape hierarchy of things. And then when you update the shape, you don't just you just update this kind of shape, or you want to change color of some shape, you know. It's just keeping a shape hierarchy. And this is not done in Direct 2D or Direct 3D. So I mean, Direct 3D, yes, you can kind of keep buffers on the GPU, but it's still, you have to keep hierarchy of shape somehow. So let's imagine then on the begin render, then I'm going to access the resources, and I will say update time. On the begin render, I will update the time. On the end render, any demo or something you got? Yeah, sure. I mean, you can go like on the, because if I now compile, this won't work. Okay, let's do that. Let's just, for simple thing, let's just return these two lines, and now it will work. If I return these two lines back to when it was, it should compile. It should compile. Now all of these, okay, all these functions actually stay. I want to go to the node editor and then go to the here. I will say that I'm actually kind of begin. Yeah, I will call begin render. So yeah, this is the node editor, and this is the main project that uses the rendering engine. So it's I mean, you can load a graph, you can execute a graph. It executes it in parallel. Check out the other streams for the JIT parallelization we were building, and I've built a lot more from there since then. And then there's like there are image viewers. This is kind of really cool. The node editor is really cool. It's laggy, but this is not the rendering actually being laggy. It's because I'm remoting to my PC. So I'm using my laptop to just stream, and then I'm remoting to my PC. And since my PC is not here at the house at the moment, so it's actually here's like load some image. It transforms to raw. This is like some simple graph just to say that the parallelization works. Like if you have some really huge things in parallel, it should like just execute them in parallel, and then like you're recombining the image, and then on the output you're getting kind of the same. I mean, not the same image, but you're getting some image back. There's some other graphs that I can. Like this kind of graph. Now it started raining. Now this kind of graph, just what it does, it's kind of very interesting. It has like two nodes. Let me set up the level to 6. It just grabs a map from the United States. It's quite a big map, and then it grabs a topological like the satellite map, and then it kind of blends them. So like a node blends them together, and then there's like some other things here just to try out some other nodes. But each node is, like as I said, it's defined in a separate DLL file. So I mean, multiple nodes can be defined in one DLL file, but the node editor knows how to read the DLL files, and then it's a graph based. It's not an image editor. It can be like any. You can define any kind of node, and then you can define some inputs and outputs on a C++ like DLL file, and then the node editor will know how to render these, and we'll know like if there are sliders or if there are constraint values. It's like really dynamic definition of nodes. So like you can have anything here, absolutely anything. We have already 140 different nodes that are loaded from like 6 or 7 different DLL files, and like each node is defined custom. So each node, like you can define stuff that anything, like all of these nodes are defined in like one DLL file, and which is pretty cool, right? And like you can do like each node is itself just a function essentially that like defines few inputs, few outputs, and like you can define anything. Really, I wanted it to be an image editor. Mostly, I mean, I was looking at this as from the point of view of an image editor because I kind of like doing photography and I kind of like doing that. But essentially, our laboratory uses this for geospatial analysis, for things that like that they need actually for some AI things. So like you can load an image. You can even load an AI model. I have written actually a parser from darknet, the library, and then I just kind of made just a parser that parses an AI model on the nodes. Like every convolutional layer or every kind of layer is like one node, which is kind of cool. Yeah. So okay, so let's here. Okay, let's say that the rendering engine here will say render engine begin render. Hey, render now end render. Should we include the render of debug? Yes, we should. Maybe the begin render should be even here, which is kind of cool. Now, oh, it's now. I mean, I have around to 6 o'clock I can stream, but I really want to cache in these text layouts so I can just see how well it improves this. At least a little bit to like compare improvement. On the render, on the end render, I just maybe I'll just say should I say resources clear unused cache, but this will always like iterate through all the shape layouts once again, which is not really cool. I don't want that on every end render, but we'll kind of manage that a little bit later. Okay, so let's say begin and end render. Now the cached resources are cached. Okay, I want to add one more function on the render resources, which is like get current stats. And this kind of I want to return some maybe struct because it will be easy to just return a struct caching cache stats, and this will be like is this C++17? Yes, it is C++17. Some projects are actually, we're kind of migrating to C++20 now on some like the newer projects. Some projects it depends. Some things are not yet migrated fully, but so we're keeping C++17 as our standard as far as we go. And of course, and what is this? What did I want to do? Cached layouts. Then I wanted to have cached fonts. So I want to print out these statistics. Then current time, and then cache stats. Get cache stats, make this a const function. It's I mean I would like to have C++20. I just cached layouts. It's just not up to me because this is many people work on this code base, so of course I have to cast them to integers. I don't think we'll ever have to deal with. We shouldn't deal with size t. Now here cache stats, get cache stats. I will add maybe or some like other statistics here, but for now I'll just return resources get cache stats. And in the node editor itself there's a debug information where debug is rendered. There's this render render debug info. And I can just add here on the debug info, there's like the JIT parallelization is enabled, but I want to render out I want to render out or maybe I shouldn't render it for now, just to not add additional text layouts. No, let's render it. This is in the same text layout, so it's going to be invalidated as well. So here against the GPU after GPU time, there should be mRender engine get cache stats auto cache stats, and then there should be like debug info std format, and this is text cached text layouts. Let's do that, and let's do cache stats cached layouts. Let's not do cached layouts, cached text layout, just to be consistent. Okay, there's no usage here. Cached fonts. Current time. Render engine. Internal time. Okay, so now this should work. It should now we should now go to this and find delete this. Now the caching should work. You said C++, but you're using std format. Yeah, this project uses I think the node editor. I mean, is std format only C++20? I don't know. Yeah, it's C++20. So apparently, yeah, the node editor uses C++20, but it does. The libraries do not use C++20. I think like some of them, because like if I take a look, some of them use C++. Let me see. So there's like static and dynamic libraries, but like if I go to core and if I go, what is this now? I cannot see here. Okay, this is C++20 on debug version. It's on release. It's C++20. So apparently, maybe I know that. Wait, the Gamma Fusion suite is not. No, this is C++17. So some things are C++20, some things it's just not. It's it's not consistent through the code base because it has so much debug. It has so many things. Okay, so what is now here? We see that okay, the rendering time increments. Text layout cached is 61. Now we have 0.5 seconds and 3.9 milliseconds. I think this is faster, but sometimes it goes up and down. I mean, the measurements of this kind of edit, and plus I don't know, did we make measurements from like I think we made measurement that we had smaller window. But now smaller windows, for some reason, the GPU time gets higher. Okay, cache text layout is 61 and cache fonts is 1. We know that cache fonts is 1 since we don't use other kind of idea here, but I think this is okay. Now I maybe like want to make the GPU time render time just like a little, the window of the GPU render time longer, and this will kind of stabilize it because there's like sliding window here when the time is rendered. But it's good to see that there's no leakage. But 61, is that like really 61 text layouts here? Different text layouts? A way to find out about this is just to copy many nodes and just to paste them. Yeah. Now it says on 60, stays on 61. When I copied many nodes, at first it kind of jumped, I think, to 71, and then it back down to 61 since maybe like the caches is removed or something like that. So I'm rendering, so maybe we should do a graph where like we render, I don't know, 10,000 nodes. Now we're rendering like 2,500 shapes, and we have like 7 milliseconds of render time. I mean, it's a lot of shapes considering that we're rendering on like 4K screen here. Like, no, maybe we should do like some controlled experiments before and after. But like here we're rendering 4K at 4 samples per second for multi-sampling. Yeah, let's create a longer GPU sliding window because GPU time kind of fluctuates. Let's open up the GPU thing here. Okay, GPU kind of rised a little bit from these nodes. But there are considerably many nodes, right? Let's just delete these and see if I get them better. Oh, this is very poor measurement. Let's do that. Let's make, let's make maybe like this. Now we have like 9 milliseconds, and then the GPU is quite bigger. And the text layouts are still cached, rendering time goes up. Now let's save this graph. Let's export to JSON. Let's go here, 4, and let's write again on the notepad. Then we'll revert the changes. We'll say this: 4K screen, full screen, 9 at average, like 9 point, what is this? 9 milliseconds. And now I don't know the GPU timing before. Okay, let's make like this. Let's here on the render. Is there on the notepad or on the? I think sliding window. Every GPU time stats is. It's not 50. 50 is too small. That's 1 second. Let's go to like maybe 300. But GPU stats is one thing. GPU stats get average. Render time, on the other hand, is in the rendering engine. Here, sliding window. Let's do that 300 as well. So let's again, and then we'll measure again how many milliseconds is on average this. It should improve. Like, we should see a little bit of improvement at least, I would think so, because we're not creating these text layouts. But maybe the whole idea is that on create text layouts it does not actually do that much, but it actually creates just a base. Maybe we should work we should take a look at internally how it works. C++ over maybe C, Rust, etc. Presume it's because you're most familiar with C++. That is correct that I'm most familiar with C++, but the actual the code base from the laboratory existed way before I got to work for them. So there's this is actually I got the job because I knew C++, and they worked already in C++. So it's 8.8 milliseconds on average. So we'll say 8.8 milliseconds on average. And the average GPU render time, it kind of fluctuates quite a bit. Now 1.6 million, I'm working for the Gamma laboratory, which is apart from my faculty. So it's just we're mostly research laboratory with kind of many different projects and different publications, like mostly assistants and professors. Okay, so render time seems to fluctuate a lot. GPU render time seems to render time does not fluctuate because Google Chrome is something. Google Chrome is when you open Google Chrome, everything just okay, so GPU render time seems to be around 1.5, 1.6 milliseconds right now. So let's say 1.5 milliseconds. But sometimes slower, sometimes 1.1, 1.2. I don't know why it fluctuates that much, but okay. Okay, so let's assume now that we have this done. I can now say, okay, blah, blah, blah. Let's open up a new branch. Let's call this render engine improvements. Let's go this, let's go that. Of course, I will make the commit better, but I just want to go back, and I want to rebuild that because I have like to do some kind of off-stream things. I don't have a lot of time right now. We just really don't have a lot of time. I have to go at 6 o'clock my time. So the thing is that you could do fuzzy testing with I could do like many different graphs and then like just see to eliminate some things, like let it render for quite a bit and then do like averaging, do standard deviations, some different things. But I don't have time to do all of that stuff. I just want to see how is it something remarkably better that we cached the text layouts and that we did not create it, or is it not? So it seems that the render time got 2 milliseconds faster, or 3, or maybe a bit more. But the GPU time really fluctuates, so you cannot tell about this, the GPU time. But the render time is like, where do you live? Also, when you're supposed to submit this master, the master thesis. Wow, okay, like this is very, very bright. The master thesis, I have quite a deadline to submit. So, I mean 1 year. No, not 1 year, 8 months maybe. I have a deadline. So, but I will try to submit it in like 2 or 3 months, and then have this. It will be. I will share it and make a video on YouTube about the note editor and maybe a little bit more. But yeah, I actually live in. I'm currently in Macedonia, in North Macedonia, which is currently, and I actually study in Slovenia. So it's quite. You go back and forth. So 11 milliseconds and around 1 point something milliseconds on the rendering time. It's okay. So I think we got an improvement. If I can, okay, let's just run it one more time, just to be sure. Let's see how consistent is this. Is it going to be actually 11 milliseconds, or now it's going to be a little less? Knowing that maybe there's some caching involved. It is 11 milliseconds, which is quite consistent, gathering that like you have, and I can move like the viewport. Of course, the viewport here will make, of course, and then multi-sampling, all of these kind of things, kind of change the GPU timings, but 11.2 milliseconds is quite consistent. So we got an improvement of what? Let's go here. So just caching 11 point. Okay, let's be generous. 11.4 milliseconds. Because now it fluctuates to 12 or whatever. Okay, let's be generous. 11.4 milliseconds. And this is, I would say, the GPU is 1.5 milliseconds, because I don't think the GPU time will improve by caching the text layouts, but what it can improve is that then later I can cache the text layouts on a separate texture, and then I can just kind of plot this texture, and instead of drawing the text layout, I will draw the texture. So that would be a microsecond improvement again. But after we transform the rendering engine from direct 2D to direct 3D, that would be possible. So we got an improvement of what is this? 11 what is this? 2.6 and then 3.3 milliseconds. Where's the calculator? 3.3. Why does this doesn't work? 3.3. Where's the divide button? Divide by 11.4. No, why am I saying 3.3? It's more than 3.6. 3.6 divide by 11.4. It's like 30% improvement on the rendering time, which is quite a lot. Considering that there's a lot of these text layouts here. Now, if I zoom in, you will see that the rendering time improves quite a lot because I have cooling enabled. So when I zoom in or zoom out, I don't draw all of these boxes. I don't even iterate through them. I just kind of I just say, okay, these are not visible, then this should improve. And I have a lot more improvements that we can do to the rendering engine. But drawing this on like this many, I mean, yes, of course, the GPU takes a lot of, but I think, okay, let's just try one more thing before we go. Before we go, I will do this. I will go, where is this direct 3D, D3D control. What is this? So instead of 4 samples, I will say 1 sample. And this will, now for sampling, I think there is D3D control where you can do some kind of other anti-aliasing techniques instead of just multi-sample anti-aliasing, which is quite more GPU intensive. But if I'm doing this, you'll see now that there's like aliasing problems. You see, like there's like anti-aliasing problems, but this should now quite more improve the GPU timings. Or maybe not just improve the GPU times, but the GPU usage. What? 15 milliseconds for what? How? I'm baffled. How is this 15 milliseconds? How is this slower? Okay, I have no idea. Are we measuring GPU render time differently? Or are we using different pipeline? This cannot be. This cannot be slower. I am measuring GPU render time differently, maybe. I mean, the render time does not change here, the CPU render time, but the GPU render time just increased a lot, which should not happen. It is possible that we're using some threading things, but what's the course you're doing in your college? The course is essentially like computer science, but with more focus on like some artificial intelligence and some like it's sorry. This is the faculty for electrical engineering and computer science and informatics. So it's Slovenian faculty. It's pretty good. It's not it's not the biggest Slovenian faculty, but but still I've learned a lot, and I guess yeah, people are very nice, and it's a small town, Maribor. I really love it. I really enjoy it there. Um, so now here I see that we are measuring it somehow differently, the GPU time. So I have to debug why is this the case. Why is this the case? But for now I will leave it 4, and then I will see the direct 3D what actually has this to offer, and like this may be depth and stencil. These are kind of things that have to like be configured properly in order to everything. But okay, the text layouts, caching the text layouts do improve a little bit. I mean, 30% in CPU render times is huge, but we could improve it far better. So any plans what you're going to do after the masters? Probably just either I would guess just work for the laboratory and go from there. You know, you never know what can happen. And I don't want to just spoil something, or maybe we'll see. Maybe work on some cool projects. I would like to kind of now work a little bit on the YouTube channel as well. I haven't done anything for competitive programming quite some time, so I would want to do that as well. So yeah, it's kind of cool. Coding is very cool. Coding relaxes you. And as far as did you do or no? Unfortunately, not yet. Of course, it's just no, it's not. I mean, it's not. I tried my videos to have like a lot of quality, and it's very hard to produce videos that have high quality production. And live streams are easier. Live streams are way easier because you don't have to edit and you don't have to think about these videos. But there are so many projects I want to showcase on YouTube. I have done like cool, interesting Blender projects, cool, interesting with Blender notes. I have done like with some geometry notes. I've done like some even simulations of like neural networks, some things like that. I don't know about Twitch. I don't quite like the. I don't know. I don't like the atmosphere that like its Twitch is more gaming related, and it's it's a platform which I'm not sure, you know, like maybe I will get more views on Twitch, but then you have to deal with then there's like you have to I have to research that. I haven't actually to be yeah Zolding I mean Zolding is very good. I really like his approach of like doing everything in C, and I mean Zolding is kind of top of the line, and it's always fun. Yeah, just see it's I have tried coding something in C, but this really quickly becomes really quickly like you wish that you had some C++ features in C. So I have been working on like on C++ like when you're doing competitive programming you're just coding like in raw C++ without any kind of abstraction layers. Like now here we have like huge abstraction layers, you know. I mean not a huge abstractions layer, but it you kind of have like Rust in C++. So you have like these objects that are I objects, that kind of hold references and can lock and can unlock and just kind of deal with all of these under the hood issues that C has. Like with multi-threading, you have to think about like, okay, when you're making a reference to some object, like, you know, you have to lock the reference counter, you have to increment the, you have to have an atomic reference counter, you have to do all these kind of things, and all these are under the hood. And when you have this, it's very easy to like just do something more and something more, and it's pretty safe. So like you don't ever get like I don't know, like dereference exceptions. Like if you're careful enough, like you don't do that. You don't. It's pretty safe, and you just deal with all of these abstraction things, and the language kind of it's super fast. Like there's no need to like, and you're also dealing with static abstractions as well. So, but I really love this kind of idea. Let's go like I mean, what was this? Dispatch by. There was this function that I called it some time ago that I kind of like. How much standard lib are you using in this or trying to avoid? No. It's the standard lib is very much in use, and we are using it more and more. The thing is that this code base was made quite some time ago, so like 10, I don't know, maybe more years. So like a lot of these like infrastructural designs, and then back then the standard lib was not even as powerful as today, right? So you had to code everything, and even like in the standard lib there's I don't think for example there is like like you see, like for example in the standard lib I don't think there is a scoped variable, and like these utility functions that could help you are all coded in by us. So it's not that much legacy, but it's still quite fun. And there's like let's say this dispatch by value function, and like you have like all these value types, and you can call a function and give the value type, and then you just get this parameter here, and you can decay this type from that parameter, which allows you to, according to the value type, allows you to do some operations on some like specific kind of arrays, let's say. And these kind of things, that like these statically typed things, are major improvements. Yeah, let's say the scope variable, like what we have like in core, let's say, was just one example that I picked. Like there is this struct scope variable, for example, and it's just a simple struct that like you have some variable and you get the reference of this variable, you have some initial value and you have some reset value, and when this goes out of scope, the variable is set to the reset value. And then this could be used as like if something goes out of scope, then you reset a bool, or if something crashes, then you reset a bool. And like this kind of utility functions, or let's say that there is like this core string split thing, like, okay, let's say that this function right here, like I don't think there is a split function in C++, you know, but or like replace. I don't know if std string split exists. So you have to code all of these functions on your own, right? So these are crucial functions for anything, right? For string processing. You have to use for example istring stream to like do that, which is painful. No? All of these, maybe you could take a look at CRTP. CRTP, recurring template design. Oh yeah, I know that. I think the what is the idea behind that? I name using X itself as a template. Yeah, we use that. We use that. We use that pattern. Oh, but view is std C++ 20, right? And then there's like the view is just only creates a view. It does not create a string, as far as I know, right? It returns. Oh, why is this documentation so bad? See, indirectly comparable. Okay. Okay, this is what requires templates call signature. Yeah, ranges view, right? Of normal runtime port. Yeah, okay. Yeah, CRTP is used essentially in the extensions. Yeah, this kind of design. Yeah. Yeah, it's actually used in the extensions. Ranges. Yeah, the STD view is cool. I mean, the ranges view or whatever. All of the views are cool. But sometimes you need the actual string, and then like you have to do probably conversion to the string there. Like if you want to gather like the array of strings and not views. What is even actually quoted? I've never seen that quoted. Extraction of quoted strings. Wow. Okay. So there's pretty cool. There are pretty cool things actually. In C++, and yeah, so I would guess that this is it for the live stream today. We kind of improved the rendering performance, at least on the CPU side. We will want to improve the rendering performance a little bit more and see if I'm actually like I don't. So the thing is that this rendering loop takes like every 16 milliseconds you render, and there is no way to. I mean, there is a way to render like on every edit of or every mouse move or every I don't know what, but then there should be like some callback mechanisms and some like or dispatch mechanisms where like you should kind of have a structure that deals with when to render, when only like on changes to render, and it becomes very complicated because if you want only to render on like changes and not like every 16 milliseconds, and that's why I from the beginning I just said okay, like fuck, let's render on every 16 milliseconds, and that's it. But the improvement on the multi-sampling can be done, and I think that like I just want to try maybe this on like some lower end computer and see how fast it is and how reliable it is. So I will like, maybe build it now for like package it, then convert it to my PC on like lower end on the other PC, and then see if if it's now any faster or how responsive it is. But for me, it's very responsive in Notator, even if you have like hundreds of nodes. So okay, so that will be it for today. Thank you guys so much for watching, and I hope to see you on some other videos or some other live streams. If you have any questions, or if you check out the channel and the GitHub. So there's GitHub with tons of cool projects, Yeah, I will. OMG 9G60. I will remember you. Actually, it really makes my day to see you. To see people like you, and um, actually appreciating what I do, and a little bit like, and really knowing their stuff, like really knowing their stuff. And I'm learning as well, so like everybody learns every day, so you learn some new things, you learn some other things. So yeah, thank you guys. Check out the GitHub and the channel, and I hope to see you again.